Can a human punch really hit like a speeding car? Time for physics. We're at the automotive crash lab. People always say a clean knockout punch hits like a speeding car. I hate metaphors. I only believe in physics. So I rented this facility to test it. Meet the Hybrid 3 dummy. It's packed with sensors and built to survive massive highway collisions. Today, it doesn't need to survive a car. It just has to survive my right hand. First, we need a baseline test. Raw, uncalibrated power with zero technique. Just pure street anger. I plant my feet, wind up my arm, and throw a heavy, looping overhand strike. The impact feels solid. My wrapped knuckles sting against the dummy's dense rubber faceplate. But the computer data is pathetic. Barely 20 G's of force. That wouldn't knock out my grandma. Rook is grinning from the control booth. He tells me I'm just swinging a 20-pound meat club. He's right. Brute force fails without mechanics. To hit like a truck, you must become one. Let's look at the actual physics. True power never starts in your fist. It starts right here. It starts on the floor. I dig my heel into the concrete. Friction becomes my kinetic fuel. The energy travels up my leg like a shockwave, transferring into the heaviest hinge of the body, the hips. If you don't aggressively rotate your core, you aren't punching. You're just aggressively slapping. I line up the dummy again. This time, I synchronize the rotation. Hips, torso, then shoulders. I drive my fist forward. The dummy's head violently snaps back on its metal neck joint. Looks absolutely devastating on camera, right? Wrong. The telemetry shows a slow, heavy push. Only 50 G's. I'm just shoving the weight. A true knockout punch isn't a push, it's the crack of a whip. You need a massive, sudden spike in acceleration. The energy must transfer in a single millisecond. I tighten my dirty bandages. I focus entirely on the exact point of impact on the rubber jaw. I won't punch through the target. I will snap the kinetic energy directly into its center. Foot pivots, hips fire, torso twists. My shoulder locks into place at the exact perfect angle. My arm acts as the tip of the whip, breaking the sound barrier right at the jawline. The impact echoes like a gunshot across the empty concrete walls of the crash test laboratory. The dummy's neck compresses brutally. The internal sensors spike so hard, the warning lights flash red. Let's look at the raw data. 120 G's of rotational force on the skull. Rook pulls up the telemetry from a 30-km/h car crash and overlays the two graphs. They match perfectly. When biomechanics are flawless, my fist generates the exact same kinetic energy as a speeding bumper. But why does that specific rotational force instantly cause a human being to lose consciousness? It's not the bone impact that gets you, it's your brain violently sloshing inside your skull. The sudden rotational whip tears the delicate neural pathways. Your brain literally bounces off the bone. To protect itself from permanent damage, your brain pulls the emergency shutoff switch, immediate system failure. The human skull evolved over millions of years to take a massive amount of blunt punishment, but it absolutely never evolved to handle perfectly synchronized rotational physics delivered by a trained fighter. Your body isn't just flesh and bone. When aligned correctly, it's a highly efficient kinetic weapon. Stop swinging blindly, understand the mechanics. Use the ground, snap the hips, and transfer the energy. I'm feeling the recoil in my shoulder, but the data proves the brutal efficiency of the human machine. Next time someone tells you fighting is just about being angry, show them the G-force telemetry. We broke the dummy's neck joint, but we proved the science. The street myth is a factual reality. What's the hardest hit you've ever survived? Drop your stories in the comments. Let's talk physics.